when you when you first turn these AV systems on, they ask you, do you want to use the projector screen? So that, from my perspective, that was my opportunity to get the screen to automatically come down in the other room. Well, it was already on when I got in there. I don't know if he had taught in there before me or whatever it was. So I couldn't figure out how to get the screen down, but this isn't a today problem. I tried to get it down like multiple classes now, 2, 3, 4 classes. I spent a couple seconds doing it. Well, it turns out that on these things in there's the physical buttons on the outside. Who uses physical buttons? So I didn't even look at the physical buttons. And one of them just says it's like arrows, like screen up, screen down. I mean, it really is obvious. And I've looked at it multiple times to try to figure out how to do it. So in the end, we've decided that it's because I never took a human-computer interaction class. So I don't appreciate the interface between human beings and technology. So I didn't think about the options that might have been available to me. Win some, you lose some, I guess. It's a thing. Okay, so last time am I already sharing? Yes, I'm sharing. I can just look up there and see. All right, so last time we got our simple hello world example loaded, right? And we created a make file for that. We had our, this is something pretty similar to it. I just, I'm kind of building my examples off of the site. So I wanted to take us to like the second step of that stuff today. So we saw that we got a module loaded in and we were able to look at the messages and see hello world in, I think ours was kernel alert, right? So it showed up in red. So the kernel info doesn't show up in red. And then when we unloaded it, we got a goodbye world or goodbye cruel world or whatever it was. So that was our simple example of a module. All right, so what's the difference, do you think, between a module and a driver? Are all drivers modules and are all modules drivers? What do you think? Driver versus a module. So let's start off with, how does a driver differ? We're not talking about proc file system yet. We did that, we did that, we did that. We did these-ish. And here's the link to that page. I added it to the slides. The link to the page I'm going to be referring to today is this code examples thing. So it's on the slides and the slides are shared. So if you wanted to grab that and open it up on your page, you can. Okay, so I'm just going to add it right here. Driver versus module. So let's start off with what's a module. We've already been messing with this. If you had to give a definition for a module, what might you say?
A bit of code installed into the kernel.
Okay, a bit of code installed into the kernel. Yeah, I think that's fair enough. Something doesn't have to be just a little bit. It could be a big bit of code, right? But maybe the extension to that is it's something that allows us to augment an already compiled kernel. But through, like you said, a generic collection of code that you may want to do something. All right, so something that augments an already compiled kernel. And we can say that this guy likely performs some kind of logic. But the definition of what that logic is isn't really, well, what that logic is isn't really defined by the fact that it's a module. This could be something that does a backup of some folder or something like that. So maybe inside your startup, you have a thing where you install a module and then you also remove the module. And what ends up happening is by installing a module, you trigger its init function, right? So its init function might do something. And then when you uninstall a module, it triggers its exit function. And that exit function might do something. So maybe you have, let's say every single time you restart your computer, you want to, I don't know, clear out log files or something like that. I'm just making something up. So, but you want to keep the old log files. So maybe maybe you have it set up to install a module, and the module goes and it copies the current log file from someplace to like a folder where you have your backup log files or whatever. Then it creates a new empty log file. And then on exit, it maybe puts a single entry into that log file saying, the date the log file was created or something like that at the top, even though you can get that information. I'm just making something up at this point. So as part of the startup routine for the computer, it installs and uninstalls the module, taking advantage of the fact that those two functions get called automatically. All right, so that's what a module is. Now, when we say a driver, what is a driver and how does it differ from a module? Are all drivers modules if we're talking about Linux? That direction, that's probably a true statement, right? Every single driver, actually, I actually do think it is true because I think Linux itself uses any drivers that come with the operating system, it installs them as modules. So they're just pre-installed modules. So we can say all drivers are modules, but not all modules are drivers. So what differentiates a driver from a generic module? Okay, so we can, so what she said is a driver is supposed to communicate with some kind of hardware. Hardware might be a little bit of a blurry area here. We probably want to say that drivers communicate with a device. And more than likely that device is a piece of hardware, but it doesn't actually have to be. Devices in a POSIX OS are all represented through files. So technically, it could be something that is virtualized. But generally speaking, we think of driver as the software that controls a piece of hardware or something that's pretty much acting like hardware. All right, so that's what our driver is. All right, so we started off last time, and do I have it open over on Linux? I do, but actually I have it open here anyway, so we'll just do here. All right, so we started off with this very simple module, just proving how modules work. Okay, and we have our init and our exit functions. Remember, we can name these whatever we want. We just link them later on in that program down here. So we have our module init, our module exit. So that's where we can actually link those guys to the operating system. All right, we saw the license thing last time. So I mentioned that there are some licenses that do exist that you could link to your module that would come up when you start doing some of the message searching stuff using some of the Linux commands that let you look at modules that are loaded. I would say licenses aren't all that interesting from a, hey, I'm writing these things perspective as a hobby. But when you start getting into actually writing drivers for industry, if something is proprietary, you need to put it underneath a proprietary license so that somebody can't steal your software. But if something is open source and you're inviting people to elaborate on it and things like that, you'd want to use one of these licenses. Not overly important for us. Okay, so now as we kind of keep going here, and this kind of goes off of what you said about modules or computer programs, right? They're computer programs that are bolted onto the operating system. We maybe add to that they have access to kernel space. Let's call it kernel memory space. That's really what we're talking about. The running operating system is living in memory. That's the aspect of it. Technically, they would have access to areas of the file system that maybe only the super user would have access to, because these programs are running as administrator. So if you did need to have rewrite access to some, for example, log file, you would get that through a module, because module elevates your privileges. And we saw this last time when we first installed the module, we did the ins mod command. We did a sudo before that, super user do, and it worked fine. And then after I uninstalled it, I did an example where we try to install it not as super user, and it screams at us, right? Basically, it's saying, hey, look, you're installing this module. You need to be super user to do this, because this module, this program can run as super user, and it can do stuff that super user could do. So know what you're doing type thing. All right. So as we've already seen, plenty of these Linux commands take command line arguments for different things. So that kind of that cadence of, we could think of command line arguments. Let's add a slide for this. As modern computer users, it's not something we're overly used to dealing with, because most of our stuff, you just double click on icons and stuff happens, right? But if we think about command line arguments, think of our system programs. Let's say system software, so it matches the name of the class, as living functions that exist as available, let's say as part of an OS API. When we think about functions, we think about what they do and what parameters that need to work. All right, so it would seem reasonable to us if a module is a computer program that's effectively has permissions to run as super user. It might be helpful for us to be able to load certain things into a module when you first install it, getting some real-time dynamic information into it. Maybe it's a date, the month or something like that. Not that you couldn't get that through software or something, but you know, maybe it's a random number you're generating for some reason, but passing something into it that might be beneficial. Maybe it's who's currently logged in, or who was last used the system, something like that. We might want to pass command line arguments to this program and have them processed as part of that init, or as part of the logic that we're doing inside of that program. All right, so as an example, we have another function called a module param. You know, we've already seen these couple of functions up here, where we have our module init and module exit. We also now have a function called module param that allows us to pass something into a module. All right, so we have an integer. We call module param, passing it that integer. We pass it the type. We pass it the default value. That's what it's expecting there. Notice we even have an expanded version of this for a module param array. Why do you think we have a module param and we have a module param array? What's the difference between primitive types and arrays? Just normal programming. What's the difference between an int and an array of ints? Besides the array being a collection. Let me give you an example. Int A is equal to 5. Int array AR is equal to a new int array size 5. What is the difference between the values stored in A and AR? What kind of value is stored in A?
Is it that they get an array as a reference to a collection of objects?
Yeah, that's true. It is a reference to a collection of objects, but I mean, so A holds an int value. AR holds a memory address. All right, so the types are different. Even though an int is a hard-coded type, we know that everything inside of a computer ultimately is a number, right? So both of these actually are numbers. A memory address is just a hexadecimal number. An int is a decimal number, and how it's stored is in binary at the end of the day. All right, so we have two separate functions, one that knows how to take in a value, the other one that knows how to take in an address. All right, that makes some sense? All right, so that's where this param array thing comes in, where you tell it, here, what's your pointer? What kind of value is this a collection of? Why is the value type important when we're dealing with arrays? What's the difference between int array AR is equal to new int array 5, and char array AR2 is equal to new char array 5? What kinds of value is in what kind of value is in AR? Memory address, right? It's an array. So AR holds a memory address. What does AR2 hold? Also a memory address? So what's the difference between the two of them? So both of these memory addresses represent the base address of the collection. Are the collections of AR and AR2, let's see, do the collections of AR and AR2 take up the same footprint in memory? Why? What's different between the footprints in memory? How big is AR? How biggish is AR? How big is an int? $16 bits would be possible for an int, maybe on a older operating system. Typically, the 16-bit data type is a short in our modern operating systems and modern programming languages. So a int would be 32 bits, 4 bytes. Okay, so that means how big is AR then? If AR is, if an int is 4 bytes or 32 bits, what's the memory footprint? What's the plot of land that we reserved for AR?
20 bytes.
20 bytes. So AR is 20 bytes. How big is AR2? How big is a char? 1 byte in certainly in Unix. If we're dealing with chars in Java, which is a virtual machine, so it gets to pick its own poison because it sits on top of the OS. It's actually a 2 byte, 16-bit unsigned value because it's representative of Unicode. But here, it'll make our example even more extreme. A char is 1 byte, so that means we have 5 bytes of real estate that we purchased for the second array. Okay, so this goes back to why is this parameter important? It tells us the size of steps we take through memory to get from bucket 0 to bucket 1 to bucket 2 to bucket 3, so on and so forth. Make sense? So we can think of this as if we have a base address and we need to walk through memory. This is the length of our stride, the size of an int. If this is the base address of an array in memory, and it happens to be filled with shorts, which we can see here. Actually, what's funny here is they actually still made it of int type for their this would be memory inefficient because they asked the operating system for enough memory to hold 4 ints, but then they advertised it as being based on shorts. So they got twice as much memory, but are only going to take short size hops through memory. I'm not sure if they did that on purpose or not, but whatever. All right, so this is a way that we can send parameters into our modules, if that's helpful. And then here's an example that does this. So they created some variables up here. So they have a bunch of things that are just owned by this particular file. So we have a short, an int, a long, a char, a couple other ints. These are int arrays, already pre-filled with a couple of -1s in this one. All right, so notice they're going to start sending in some params. They're sending in my short. My short is a 1. They're advertising that it is of type short. All right, now this is something called masking. We just quickly look up what that means. I'm guessing we could do it in a man page, but we didn't have very good luck with that last time. So these are various permission bits. Let's make this a little bit bigger. So this gives read permission for the owner of the file. And we saw change, we did a chmod in here, right? For changing the name of a file, whether a file is executable or not. We might not have. We'll see it at some point. All right. But anyways, these are effectively probably under the hood, they're an integer. And when we go back and look at this code, what is this guy? The same answer is true for C, C++, Java, C#. What's a single vertical bar? What's a double vertical bar?
Isn't a double like an OR in an if statement?
Yeah, so a double would be an OR, right? We've seen that before. We can, write some code and do something like so what is single bar versus double bar? All right, so in Java, we might say something like if, maybe we have int a equals 5, b is equal to 7, something like that. And then we do something like if a is less than 10 or b is greater than 5, do something. That's how we use that vertical bar. What would my output be if I said a single vertical bar b? Pretend like I've gotten the case correctly here. What's that guy equal? What's the vertical bar?
Does it check like the data type or something?
Well, the opposite of mod would be just divide, right? I think I've covered this in one of your classes. It's probably 2 of them, something I usually cover. And somebody online said something about data type or something.
Does it compare the data types between both variables?
Nope. So what he was suggesting is maybe this returns true if A and B are both the same kind of thing, and false if it's not. Nope. And similarly, this exists. And similarly, this exists. So this guy is the bitwise OR operator. So what do I mean by a bitwise operator? How do bitwise operators work?
Is it just true or false? Or is that wrong?
Well, let's go this route. What would the answer be here if I'm doing a bitwise OR? What's A? A is a 5. How do I write 5 in binary? 1, 0, 1. So 1 in the 4's place, 1 in the 1's place, that's a 5. How do I write 7 in binary? 1, 1, 1. So these two guys bitwise ORed together, we do it on a per bit basis, hence bitwise. So 1 or 1, for an OR to be true, only one of them needs to be true, is a 1. 0 or 1 is a 1. 1 or 1 is a 1. So the answer here would be 7. 1, 1, 1 is 7. If I steal these, go to this guy. And now I'm doing a bitwise AND. So now it's only a 1 when they're both 1. So that's a 1, that's a 0, that's a 1. So now the answer to this is 5. Do you know what the caret is? What is that symbol? Yep, it's the exclusive OR symbol. So now it's one or the other, but not both. So this would be a 0 because it can't be both. That would be a 1 because it's one or the other, but not both. So it's exactly one of them is 1. This is a 0. So this guy would boil down to a 2. Make sense? Does it make sense what this is? What it does? Not so much why we would need it. Okay. All right. So what I'm going to say here is that there's a concept called masking. And you've probably seen the phrase before too, when you've been going into your, like on your computer, if you've ever seen a setting for like TCP/IP, and there's something in there called subnet mask. right? Not that you necessarily knew what it was, not you necessarily knew what was happening, but it's always like 255, 255, 255, 0. Okay, what it's doing is it's taking those values. So those are 8-bit unsigned values, right? 0 to 255. And it's using it and it's doing a bitwise operation against another IP address to get you an outputted subnet that these IP addresses might live on. So you can actually translate an IP address that's on a local network you can mask it to find out what its subnet address is. That way you can have a computer that lives on a local network with an IP address, and you can have a computer that lives on a different local network, but inside the same larger network with the same IP address, but you can uniquely identify the two of them based on their subnet, which is calculated with that mask value. So one of them, it might be 255, 255, 255, 0. The other one, it might be 255, 255, 0, 0, for example. So you would, even though you have the same base IP address, you might get different masked values between the two of them. All right. Now, we use masking in a situation like this. It ends up being just a math pattern that happens. But notice here that we have, so I promise you that guy's just some number. He's an integer that would ultimately end up getting stored in binary. Okay, so there's a list of these things, and I think I just brought it up, right? We see there's a whole bunch of crap in here. Okay, and each one of these kind of means different things, like read permissions for the user who owns it, read permissions for the group, read permissions for the other people, whether, here's the execute permission, so that we have read, write, execute, kind of the different things. So we have read, write, execute for the owner, read, write, execute for the group, read, write, execute for everybody else. So each of these has like a number assigned to it, number of a bit. So the idea here would be, if we go back, it's in the web browser. Here. The idea here would be is that we have read access for the user, we have write access for the user, we have read access for the group, we have write access for the group. We want all of those things to be available for this particular integer, for, depending on who's running the program, running the module. So now with that in mind, each of those is a number. So when we bitwise OR those numbers together, we're going to end up with a number. That number is unique for these 4 things all being available. You will get a single unique number that means these exact 4 things. Does that make sense? So somewhere there's going to be a lookup table for every permutation of read, write, execute permissions for user, group, and everybody else. And based on because ultimately what I have highlighted there is going to get sent in as just a number. You're going to get just some random stupid number, right? And then you're going to say, well, what does this number mean? The reason why they give us usually you can tell when it's in all caps like this, they're called macros, like a constant value. So somewhere somebody's written a file that has, next to this one, maybe it's the number 1, and this one is the number 2, something like that. So rather than us just seeing a 1 ORed with 2, ORed with 3, ORed with 4 here, we're like, okay, well, what does 3 mean and why? They've given us almost equally hard to read acronyms for something, but still better than a random 4, right? Where we can say, here are all these things. When we OR them together, we get a number, and that number has a unique meaning to it, which means that all 4 of these permissions are present. This would be called the mask, where we bitwise OR them together, giving us a masked value, and that masked value gives us a unique number that equals having all 4 of these permissions. Okay? Ultimately, the reason we have to do stuff like this is because in computers, everything's a number, right? So we're passing numbers around, and we see this. We see this with web pages when sometimes you get an error on a web page, you get like a 404 error or something like that. Well, somewhere, if you go look up, there's a chart what all those different error codes mean, right? A 404 means one thing, a 500 means something else, so on and so forth. Well, the same thing's true here. Whatever number these guys OR to means something that can be used for the processing behind the scenes. All right. So we can pass in a parameter. We can give a description of what the parameter means if we want to. Notice here that this is kind of name value pairs, right? Here's us actually sending the value, and here's us associating a description with a value that would have been previously sent, if that was interesting to us. I'm not sure I would ever write that, but kind of this is how you document your modules. So more parameters getting sent in, so on and so forth. Now, notice these things, these are all at the top. So these module param things, these all came before our function call. All right, our function call still happens the same way as it happened before, right? Where we are initializing it, we're Xing it somewhere else, we're going to be ins modding it to add it into the kernel. But as part of this function, so hello 5.c here, which is just an expanded version of what we wrote last class. At the top of this guy, we have communication with the module library, passing values in that become available. If you remember back to one of the earlier slides, I said something along the lines of that you have this global namespace for modules, and the variable names need to be unique. Okay, so what does this mean here? Is when I'm passing these parameters in for our modules, what I'm doing is I am throwing these variables into the module subsystem, not necessarily to my specific module. My specific module is likely going to be written to take advantage of these, otherwise I probably would not have put them in here, right? But it's not like I'm passing them directly to my program. I'm passing them to the module subsystem, which then will make them available potentially to all modules, which could be a good thing, right? If you have multiple modules that you're writing and they all have to kind of share some global values or something, that could be good. All right, but that's why that one of those early slides mentioned that we need to be careful about how we name those variables because they need to be unique, right? So I don't know, this is probably a slightly dangerous calling this guy just my short, because if you're somebody who's following just some random tutorials, you might have 3 or 4 tutorials that all name a variable my short. You just keep overwriting each other. So whichever one was the last one you installed is going to be the one that has my short's final value. All right, so I think the slide kind of mentioned maybe naming your variable something fairly verbose, like name of module underscore variable name, something like that. You remember this slide? Somewhere it was near the beginning-ish. I just want to make sure I'm not lying to you. Pretty sure I'm not. Naming conflicts. Represent a single program module, use a single global namespace. This guy. All right, make sense? So if you want to simplify that in your mind, these are all global variables. Anything you pass in as parameters, they're global variables available to all modules. Name them as such. so if you want to have something that only kind of you know about, like I probably wouldn't put a variable up there named I. Although it might be meaningless enough that it might be the only unique I because everybody else is following the rules by naming their variable something reasonable. Okay, so get back to this. All right, so this makes these variables available to global namespace, global module namespace. Then we're doing our normal, we're doing kernel stuff. But notice here, we're saying my short is a short integer. We're doing a %HD going to give us the placeholder for it. I think HD is specific to modules. No, it's not. So this is for a short. It's not specific to modules because %d is just a normal int for a decimal. So just like printf, this is a placeholder for a short. This is a placeholder for a decimal. This is a placeholder for a long, placeholder for a string. And these are the values: my short, my int, my long. But notice that we didn't actually locally define variables called my short, my int, my long. I don't have a variable here called int my int equals 7. I didn't write that. Instead, it lives up in module namespace. So right here, because this guy is a module, when he was installed into the module subsystem, he gains access to the variables in the namespace. This is part of why we have to build our modules a certain way so we have access to that namespace. All right, so when it goes to, remember, all variables resolve to their most local definition. Nothing's changed here, right? So what's a normal programming language going to do? It's going to say, here's a placeholder for a decimal. What variable do you want me to put there? My int. Let me go and find the value for that. It's going to look around locally and say, do I have a variable I've defined in here called my int? Nope. It's going to look more globally in this program and see inside of my program right here, inside of this hello-5.c, did I define a variable called my int? Still no. So now it's going to say, under normal circumstances, we would say, now this is an error, unless my int was defined somewhere in here. Go ahead. Right, this exposes it to the kernel space. Because this is, by making it static, it's owned by, we were thinking about this in terms of Java, this is owned by the class. We don't have classes here, so it's actually owned by the module. Okay, so its value came from this. But if we think about this in terms of Java, we always access static members using the class name itself. So this guy would be the module name that we would access these things through. That's exposed to us, I think it's through kernel.h, is our access to the module namespace. It's possible it's from module.h, but I actually think, if I remember correctly, it's kernel. But it's someplace else. It's stored. It's potentially shared. All right. These values can get associated here, but the way they link up, these variables have to be static. All right. So we're showing that we have access to these guys, and we're going to see how it's called here in a minute. So we have access to these guys through that global namespace. Oh, look at that guy's username. All right, so notice here when we were installing our mod, the mod we're installing is hello 5. This is our compiled version of it after we went through the whole makefile thingamajig. But now notice that we are associating values here. We're passing in my string is bebop, my byte is 255, my int array is -1, which I'm presuming is just means it's empty. It's an empty array. All right, so it's passing in those values. So let's see where we say my string. So my string, this guy down here, bebop, this guy down here, bebop, is getting its value, my string, which we did define here. We gave it an initial value that got exposed to the kernel called blah. But because when we installed that module, we passed in a different value for it. We said my string is actually equal to bebop. That overwrote that variable in module space so that when we went and used it down here, it grabbed the value that was passed in as a command line argument to the module. That makes sense? So down here, we're seeing how installing the module allows us to pass in command line arguments. Here's the output of that module. Presuming, I don't actually think it will print to the screen just like that. Does kernel info do that? I think it still goes into that message thing. Whatever, doesn't really matter. The output's what matters in this case. All right, and then we removed it and we did our goodbye, and we see this guy is has just hard coded a 5 in there for, I'm not sure why, just did. Okay, so there's our example of sending command line arguments into modules. Is that helpful? Maybe. Is it not helpful? Maybe, but it's something you can do. Okay, so I'm going to probably skip this next time. This is just saying, hey, what if we're starting to see these guys getting a little bit more complex instead of just 2 lines of code. Let's just assume that you might have an init function that is 500 lines long, and you have an exit function that is 500 lines long. When we start thinking about this is C, this is a predecessor to object-oriented programming, it seemed like we moved into the direction where we wanted to have things kind of modularized to kind of keep our code organized better. It might make sense for us to have our init function inside of one C file and our exit function inside of another C file and build our module that way. It's really no different than what we did. The make file changes just a little bit. So, call this a convenience type thing. I probably also won't do anything with that. Talked about that already. Next time, we're going to start with device drivers. Okay, because now we're going to say, how do we basically read and write from the files that live in the proc file system? All right, so we'll talk about the proc file system on Monday. You might find it interesting to go through and get this code typed in and see it work. If you wanted to, I won't give it as an assignment for Monday, but if you just want to see how the command line arguments work, I think it's fairly self-explanatory, right? They really haven't given us an example of why you might do this at this point. I can't come up with a good one right now. Once we get into drivers, I'll probably be able to give you something. But so no homework for Monday officially, but I might encourage you to go and type this in and see it work. And we'll start with device drivers and the proc file system on Monday. Questions, comments, concerns, bribes? Keyword static existed before object-oriented programming. Just in object-oriented programming, we say that static means something belongs to the class. In procedural programming, static means it is accessible, in our case here, to the global kernel module. All right, I'll see everybody on Monday.